Okay, so I wanted to split up our two problems into two different things, so the videos were kind of separate. This first one, a coffee machine dispenses coffee into paper cups. You're supposed to get 10 ounces of coffee, but the amount varies slightly from cup to cup. Here are the amounts for a random sample of 20 cups. Is there evidence of short change? So because it's asking for evidence, that's kind of asking you for a hypothesis test. And so remember, here are the 4 parts you have to have for a hypothesis test. You have to write the ho and the ha, the conditions, parameters, and name a test. You have to do the calculations, and then you have to do the conclusion. Okay, so let's start off by figuring out our null and our alternative. So a coffee machine dispenses coffee. We're supposed to get 10 ounces. Okay, so the null is that, remember, hoes never change, and so it's supposed to be the original amount. So the coffee maker, the coffee machine dispenses 10 ounces. And so mu is equal to 10. Okay, and then it's asking if you shortchange. So shortchange would be less. So the coffee, look at that, machine dispenses less than 10 ounces. So mu is less than, oops, not equal to, just less than 10. Okay, so we got our ho and our ha. Now what we need to do is check our conditions. Okay, and so we have 20 random cups, and I'm going to combine that with less than 10% of all cups of coffee is less than 10% of all cups of coffee. Table shaking. And then the other one is coffee will be, the amount of coffee is independent. Okay. The last one is we have to look at the histogram, right? It's not above 40, so it's not big enough for us just to assume it's going to be okay. So go and you need to type all those numbers in the calculator. Okay, so enter all those numbers in the calculator and then press play. I have them all here for me already. I did it earlier so that I didn't have to do it during the video. So all my numbers are there. Okay, I can drag this over so we can still kind of see. Okay, so now what we have to do is, remember, we have to look at the graph. So to look at the graph, we're going to hit second, y equals. We're going to turn the plot on. And we want it to be a histogram. Okay. And then we're going to graph it. Hit the graph button right here. Okay. So you can't see anything. So, well, let's first make sure you have this. So here's the key press history. Kind of goes in order of what you do. It's kind of weird looking though. I think most of you will just rewind the video. Okay, now I'm going to do my window. And remember, all the way at the bottom, there's a zoom stat. I probably should have went down versus up, but I think it's 9. Oh, no, I went too far. 9, yeah, so I'm just going to hit the number 9. Okay. All right, so it doesn't look great, but it is roughly unimodal. And it's kind of symmetric. So this is a good enough shape with the size of 20. Okay, so we would say histogram is unimodal and roughly symmetric. Do not ever say that it is a normal model. You could say it is an approximate or normal model, or something about it being almost a normal model, but never say that it is a normal model, because then nothing ever is exactly a normal model. So you have to be careful with that. Okay, so now we got our conditions, our parameters. So our mu is 10. Now we have to find our standard deviation. And so let's go back to our calculator. Okay, and we're going to go stat, calc, 1 bars, and everything's in L1. Okay, so now if you notice, you should see there's a couple different S's. There's the SX and the sigma X. The one we want is right here, the SX. I don't know if you can see me pointing my mouse at it. Sometimes my mouse moves and sometimes it doesn't. So it's 0.1986. So we're going to say it's 0.199. So I'm comfortable rounding it to 0.2. There is a little bit of a difference between these two, and it might cause you a little issues if you are off a little bit. So this one was SX on the computer, so it was 0.2. Okay, so from our calculator, we can see that's SX. Now here's the thing that's tricky is, oops, let's go back to here. So that calc 1 bars. Is that this is we still have to adjust this. Okay, so it is 0.196, but then what we have to do is we have to do that, get my marker, we have to divide it by the square root of 20 to find the standard error for the sample. So remember, sample is SX divided by square root of n, and so we still have to do that. So we're going to do 0.2 divided by my square root of 20, and so it's 0.045. Okay, so 0.045, that's what we have to use. Okay, so don't forget that step, and remember that's part of what the formula says. The last thing that we have to list here is you have to list the degrees of freedom. You don't really have to list n. Degrees of freedom are more important here because that's kind of what controls the curve. And since our sample size was 20, our degrees of freedom are 19. Okay? All right, and we are running a 1 sample t-test. I used to like to say, I like to usually say mean Mr. T, because Mr. T was supposedly mean, and he's a T for t-test. Let me show you a picture of him. Hold on. So here's Mr. T. He was in a lot of movies back in the 90s, maybe even 80s. Mean Mr. T. And so that's why you know means are for t-test. Okay. All right, back to our math. Okay, so now what we're going to do is we are going to do our calculations. Now when we do a t-test, you have to do it based off 0. Okay, so I need to find out what my mean is, my sample mean. And we can find our sample mean from our calculator. Let's see, so that's back at the 1 vars test. Remember, oops, I hit the wrong thing. Stat. Oops, I was going to z-test. 1 test. 1 vars. And so our mean is the 9 point, right here, 9.845. So the things that we're going to need are this and this. Because what we have to do is we have to calculate our t-score. And so our t-score is just like a z-score where you do your value, you subtract the mean, and the mean was 10. We were saying that it was 10, and we're going to divide by 0.045. And so let's do that real quick. 9.845 minus 10. Oops, not 1910. Ugh. Okay, we have to hit enter first. And then we're going to divide by 0.045. And so I get a t-score of negative 3.44, which is pretty small. Okay, so that's way, way over here. It probably isn't even, it probably is even farther than that, but that's what we have so far. That's good. Okay, so now what we're going to do is we're going to calculate the t when it's less than negative 3.44. And we did that in our notes earlier. Look at these examples up here. You see that? We calculated the t when it's that. So now that's the same thing we're going to do. So we're going to do our TCDF. So we're going to go second vars TCDF, number 6. I'm going to hit enter. Our lower is just a negative number, so we'll keep it at that. That's a small negative number. And then negative 3.44. And then our degrees of freedom, which was 19. And what you're going to notice on anything with the T model, that's what you always have is the degrees of freedom. It doesn't really, they don't really give you the option to enter in your mean and your standard error. You just have to enter in degrees of freedom because that's really what controls the model. Uh-oh, what happened? Oh, I hit a negative, so I need to actually use my calculator. I was using my keyboard. That's why I did that. Okay, so now I get a p value. Look at that. Value is 0.0014. That's a pretty small p-value. So here's our conclusion. With a small p-value of 0.0014, there is strong evidence that the coffee maker is shortchanging people. There you go. Okay, so it's kind of the same process we've done. The only difference is you have to use a t-score now. You have to describe the degrees of freedom. But there's just some little calculation stuff that's different. But otherwise, everything else is kind of the same.